Hey, this is Mr. James, and this is question 25 from the Properties of Quadrilaterals Tier 2 or 3 Challenge Worksheet. This video will only talk about question 25. This is the third video in this series. 25 is a little more involved, so let's take a look. A contractor is measuring for the foundation of a building that is to be 85 feet by 40 feet. Stakes and string are placed as shown. The outside corners of the building will be at the points where the strings cross. He then measures and finds WY equals 93 feet and XZ equals 94 feet. Is WXYZ a rectangle? If not, which way should stakes E and F be moved to make WXYZ a rectangle? Let's see. So let's label the diagram a little bit first. I've got this diagram down here, and it seems like we've got to add these diagonals in. So let's add these diagonals in, just like this. That's one. And I'll make the other one a different color here. Okay, make it red, and there's the other diagonal. Alright, so, and we can label them as well. So it says that WY is 93 feet. So that's this black one right here. 93 feet. And it says that HX is 94 feet. 94. So, first off, there's a couple of things we can do here to tell if this is a rectangle. First, we can think about the diagonals of a rectangle. What do we know about the diagonals of a rectangle? Well, the diagonals of a rectangle should be the same. They should be congruent. But in this case, they're not. One is 93, the other is 94. Definitely not congruent. So what would you have to do to make these both the same and so you'd have a rectangle? Well, I guess you could make this black diagonal a little bit longer. In that case, you'd need to move F out a little bit, right? F would have to go in this direction, out, away from the rectangle. On the other hand, you could make E a little shorter, right, to make these both 93. So E, perhaps you could move in towards the center of the rectangle a little bit, so that either these were both 93 or both 94. So one option is to change the diagonals. So to sum it up, option one, since the diagonals of a rectangle must be the same, you can either move F or E to the left, so the way we talked about, to make both WY and ZX either both 93 or both 94 feet. In any case, it's got to be the same for it to be a rectangle. Another way of doing this, option two, is a little different and actually uses Pythagorean Theorem and only one of these two diagonals. Remember that in a rectangle should have 90-degree angles. So that means that if this was truly a rectangle, what we could do is do 85 squared plus 40 squared, and it should equal 93 squared. If it's not 93 squared, we'll know what length this should be to make it a perfect rectangle. And so if it's not 93 squared, we can talk about, well, how we should change this 93. Should it be bigger? Should it be smaller? What should it be? And how should we move F? So let's actually do the math out for that. So again, since rectangles have right angles, we can use Pythagorean Theorem to check what WY should be if this was a rectangle. So we can set up the equation 85 squared plus 40 squared equals WY squared. If you solve that out, right, square those, add them together, take a square root, and drop that square root into your calculator to get an approximation, you can find out that this diagonal should be 93.9 if this was a right angle. Which means that this diagonal as it is, WY, is too short. It's too short. So just like we found out before, we've got to actually make it longer and move F away to make this at the proper 93.9, about 94 feet. It's actually really interesting because XZ, as we found out before, our other diagonal, this way, is already 94 feet. So in fact, that doesn't need to move at all. That's already as long as it should be, and E really doesn't have to move. But it's really F, right? With this diagonal of 93, it's got to be 94 for this to be rectangle. Alright, so those are two different ways to look at number 25, either using option 1 with the diagonals, or looking at option 2 with one diagonal and a little bit of Pythagorean Theorem. Hope that you found these last three videos helpful when looking at the properties of quadrilaterals, Tier 2, Tier 3 challenge sheet. If you have any questions, make sure to ask me, another student, or come see me before, during, or after school.